Let me know when you guys are.
I am ready whenever you're ready. I'm looking forward to listening.
All right. So my project was on welding, and this presentation will be on kind of the value of welding in the present and future. And so, basic overview. We'll go over some kind of necessary terms and an overview of the different types of welders and what they might be used for. And then we'll have a brief history of welding, just to kind of understand where we started and where we are going, I suppose. And then some of the we'll be looking at how welding can be applied in different circumstances and why it might be beneficial to learn how to weld. And that will primarily be in a repair and construction context, so farm repair or cars and trucks, and then also building things around the house, and then also using it as art, which there are some really cool ways to use metal as a medium and create structures that are artistic, and then also sculptures. And then we'll finally be looking at the future of welding as an industry. So first, my essential question that kind of guided me through this project was, what value does welding provide for everyday people? And where does it fit into our lives moving forward? Welding has kind of driven us in the past 50 years as an industrialized country, and then globally, welding kind of plays a big role in manufacturing, and we'll see how welding can kind of spur us into the future. So some welding terminology. So the electrode is the primary kind of facilitator of welding, and it creates an arc that heats the metal that you're trying to weld, so that you can fuse it. Flux is a material that is used to clean metals, and it also dissolves rust and kind of protects the welds against any kind of trapped air. And going along with flux, another protective part of the welding process is a shielding gas. You can see that these are generally inert gases like hydrogen or argon. I used argon when I was welding. And they kind of create, they'll generally be like excreted right through the welder. So the welder's hooked up to one of these inert gas tanks, and it creates a kind of protective field around the weld so that you don't have atmospheric gases interfering with your welding and making the welds weak. So the arc is the specific, electricity that heats the electrode and the welding material, creating, melting that metal and allowing it to fuse together. And then finally, filler material. When you're welding, you want to dig away basically to the two sides of your metal, right? So if you're welding at an angle, you're going to be going up and down so that you're digging away like almost like a little cave in between those two pieces of metal. And while you'll need filler material to fill in that gap, because the two pieces of metal, even though you're eating away at them, there's still going to be room to fill to create a strong weld. So a brief overview of welding. Welding is joining two pieces of metal together by heating them until they fuse. And then there are 6 primary types of welders. I learned to use I mainly was on a metal inert gas welder, MIG, and a tungsten inert gas welder, TIG. And we can look, so right here we have metal inert gas, and so MIG welding uses a consumable electrode, so it is fed through the middle of this, basically it's a gun, that when it arcs with the filler material, the welding material, it melts both the electrode, which is your filler, and so you're just like kind of heating your welding material, and then also kind of just adding more and more hot metal to that mix. And then TIG welding employs a tungsten rod, which we can kind of see right here. And so that's heated up a lot, and that's where your arc is coming from. And tungsten is really a high heat metal, so that it allows you, well, you won't be melting your tungsten. Here's your filler material, and it allows you to make more precise welds. It's often used on like furniture or bike frames or something that is going to be exposed for people to see. And if you want to do really accurate welds, you would use a TIG welder, because you can control how much metal is really going into that weld, versus a MIG welder, which is more of, it's easier, but it's more of just like general, I want to attach something together. And then we're getting into more advanced welding types. And so we have stick welding, which is another common welding type that basically it's primarily used for industrial work, and we can see it right here. And it also uses a consumable electrode, so that's your filler wire or your filler material right here, and then you're heating that point. But it allows for a little bit more control, similar to a TIG welder, but utilizing the same general concept as a MIG welder. And then more advanced welding types, electron beam welding, which fires this is generally for aerospace, on the ground aerospace welding that's, very low margin for error. So it's set up in a machine, and you're firing high velocity electrons through it to heat that metal up and fuse it together. And then finally we have atomic hydrogen welding, and this is for really high heat metals, and it employs, instead of the TIG welder using one tungsten rod, basically it employs two. And we might be able to see it here, but we've got 1 and 2 right here, and basically you're arcing between those two and the welding material. Moving on, here's a brief history of welding and metalworking. Metalworking and rudimentary welding kind of developed during the Bronze and Iron Ages, when people in the Middle East and Europe, when people figured out you could heat these two metals up, generally using a forge, and kind of fuse them together by hitting them together a lot. And we see that kind of become more, I would say, developed and advanced in 1540, which was basically when the first metalworking book was published in Europe, and that kind of spurred on all of this, or this new interest in using metal as kind of a alternative to other sources of like wood. And then welding kind of made its jump to its current form in 1800, when Humphrey Davy was able to produce the first electrical arc, and so that catalyzed the new electrical arc welding that's much easier. And then in 1802, they first created an arc in 1800. In 1802, they were able to create a continuous arc, and that's catalyzed new welding. And then in 1882 was the first time an arc was applied to welding, and so at first they used two graphite carbon electrodes, and this rudimentary welding was called carbon arc welding, and it's not used very often today. Sorry, it's a little hot, got a little hot in here. And then in 1890, the C.L. Coffin introduced the first U.S. patent that employed a metal electrode instead of like a graphite one, which was also used, and it also employed filler material. So that kind of, that was maybe the first welder that would be very, very similar to what we see today. And then finally, in the 1920s, we see the final development into welding today with the employment of inert gas mixtures. Once again, primarily argon. And this, shields the welding site from atmospheric gases, which can lower the quality of the weld and, create rust within the weld. So, I think the value of general welding really comes down to rudimentary welding skills can allow novices to fix all sorts of machinery or cars. So in an auto repair setting, will allow you to fix your, any type of body work, like, rusted frames or just the exterior body, which obviously will cost you time and money to put it in the shop. And if you even have a rudimentary welder and a little bit of welding knowledge, you'll be able to do that by yourself. And then once again, on farms, they use it a lot because it's, saves them time and money in, bringing tractors in or any of that kind of stuff that would require a lot of transport. And so having that in your tool belt is obviously going to be very helpful. Furthermore, with the internet, we have all sorts of YouTube videos and websites that really explain how to weld, so it's really a user-friendly, especially if you use a rudimentary welder like a Mig welder. It's pretty approachable for everyday people and not as scary as maybe people consider it to be. I think a lot of the public, because you have to wear a mask, right, and there's these arcs that are, can really hurt your eyesight, that there's a certain degree of fear there, but it's really quite approachable. And then similar to woodworking, it opens up, using metal to create at-home furniture or storage can really open up, new opportunities, and then the metal can take a beating. And so my project for my small internship or mentorship was to create a firewood holder, and that I was able to design and build it to my specific specifications, and it really, all I needed was a saw to cut the steel and a welder to attach it, and understanding where, being able to design that, but really it wasn't necessarily at all advanced and really beginner friendly. And so that's a great demonstration of, how approachable welding can be. Welding can also be used as art, and it's, once again, it's a different medium than maybe most people are used to, but it's, allows you to do some cool structural things, and especially we have, and then in Vermont, there are already plenty of opportunities to present kind of different welding art as well, and have it be, be public art and be utilitarian. So you could be, right, we have here, Flywheel Industrial Arts is the business that I work with in my mentorship, and we have benches, and it's kind of this brass sculpture was a entryway into the Langdon Street Alive, which is art festival basically, which is in the street. And so having all of these opportunities just in Vermont allows especially Vermonters to learn to weld and then be able to present that to the community. Welding in the future, while welding can be considered kind of maybe a dwindling industry because we have, with the growth of automation, no longer are we needing humans on in factories welding things together. There's still plenty of opportunities, especially going forward in the next few years with really cool jobs like working for NASA which they need engineers and welders to be able to design these spacecraft and satellites. And then as more private industries continue to invest in space exploration, they will need advanced welders who know the trade and can provide expertise in that field. And a lot of these companies are using materials that are very friendly for welding because it's these metals are both easy to come by and then they're really workable, which allows, these companies are tailoring their spaceships and their satellites to welding, which creates a lot of jobs. And then also there are other obscure and jobs that will take you all over the planet. Primarily dive welding, which is working on all sorts of bridges or oil extraction in the ocean, and that's a really those jobs are in high demand, and there's a lot of vacancies in those jobs, and if you're interested in that, that's a career path that will really allow you to explore while also having a stable job. And then finally, my project was learning to weld, and so I learned how to operate most of the welding machinery when I worked with Flywheel Industrial Arts, and that was using cutters and grinders to cut that metal and smooth it out so that I didn't have to necessarily be concerned with the quality of the weld. And then also, I primarily used a Mig welder, and then twice I tried a TIG welder. And then I was able to design and build that firewood holder as we saw earlier, using all of the tools that I had already learned how to use. And then finally, with a little bit of extra time, I was able to help my mentor with a little bit of metalwork, which is primarily just finishing welds, which requires an application of chemicals and then grinding down welds. And special thanks to Ben Sheeny of Flywheel Industrial Arts for the opportunity to do this mentorship program and really teach me how to weld. In conclusion, I think welding is a valuable skill that can open doors for you, whether you choose to pursue it as a career path or just a hobby, and it's just another handy skill to have in the toolbox. It will be used into the future as long as we need to fuse metals, and those jobs aren't going away. So it's, once again, a really handy skill to have.
Nice job.
Any questions?
Sorry, you
Yeah.
ask question first. I was pushing my way.
You want me to go first?
I do.
No, why don't you go first? Seems like you got something more to do.
Well, all right, so I find it fascinating that you're very academic and you're going into medicine and you chose a trade thing, and I know that your dad was like a teacher in science and now he's in construction and totally separated, and I'm just kind of wondering, like, as you explored the world of welding, did it make you kind of think, someday I might be able to do this? Or I'm just kind of wondering how you see this playing out for you personally, like, how did your brain kind of, do you see it transferring forward at all?
Well, I kind of chose this because I thought it was, once again, I think a few years ago, one of our friends, his nephew, it was like a welder and was just able to, he took his van to South America and has been just driving back to the United States for the past 4 years, but you know, his van will break down and he's able to just get a welding job, right? And so that kind of understanding, knowing the weld, or knowing how to weld is one of those, similar to like bartending or or waiting tables. You can go all over the globe, and if you know how to do that successfully, then you have a job, right? And so it enables you to travel. I think also I'm really interested in biking, and I don't know if this is at all in my future, but being able to weld allows you to design and build bikes. So having that, kind of a dream of mine is to own a bike company and build bikes. So once again, that it was maybe a little bit involved for an entire senior project, being able to, you know, in 15 or 20 hours design and build a mountain bike,
Right.
let alone very expensive. So,
Yeah.
but learning to weld was a kind of, it allows me in the future to be able to try to pick that up. And
It's a stepping stone for you.
yeah, and then also, I mean, it didn't work out, but hopefully, at least a few times this summer, I'll be able to work for Ben at that company, and it maybe not, it's not exactly what I see myself in the future for the next, you know, going in, being a professional welder, but you know, as a summer job, I think it's really fascinating, and it's never dull.
Mhm. Thank you.
I apologize. My name's Matt Foster.
Nice to meet you.
Nice to meet you. I have a special interest in welding. My daughter, I encouraged her to do it actually in her freshman year when we were in a different state. And unfortunately, I'm a big, I would say, it's not unfortunately a big proponent. I'm a very big proponent of the trades being taught in high school and having that connection there and making sure we give students enough choice and opportunities to explore whatever they want. So hats off for you to do this. I actually was going to kind of go along the lines of the medicine line. Brother, his friend, graduated in medicine and engineering, which allowed him to go ahead and design devices and things of that nature. And just as you kind of think about welding and creation and things of that nature, it just put that bug in your ear as well. Nothing wrong with kind of keeping those design skills in mind as you go into medicine, if you choose to stay that path or not. But those are not, those are complementary skill sets.
Yeah, that's totally, when I was approaching this project, I thought, well, you know, I'm taking all of these, I'm really giving myself a broad scope of academics this year. Why don't I try to learn a trade, or at least begin to learn a trade, so that that's once again another kind of tool in my toolbox going forward, where I can be like, oh, I know at least a little bit how to do that, right? And whether that's just at home or, I don't know, some job in the future comes up and I'm...
I wish I had welding skill. I've got things I would love to have welded right now on my tractor. So it's a great skill.
I have another question unless you do want to go. So, yeah, you do, go ahead.
Yeah, sure, I'll go first. Well, you made that firewood stand with Ben. Was that, how long did that take you doing that project?
It probably took me, I would say, lollygagging, 7 to 8 hours.
Well, what do you mean lollygagging?
Well, there's just a lot of the kind of tools in the shop need, and not necessarily welding tools, but just they've got like tables set out for welding that have all of these like holes in them, and you have different clamps and different ways to configure them that allows you to, if you know how to do it, really save time and not have to try to square something up and measure so much. For me, that was more of the learning curve. It's like being able to do that quickly.
Right.
So it took a while, and then also like learning to, you know, grind down a weld such that it looks nice, or a little bit nice. So somebody who's done it a while, it probably would only take them, I'm gonna guess, 2 hours.
Right.
But for me, it, you know, took a little longer.
Yeah, for sure. So that was like the project that you made.
Yeah.
So what would be, now that you've developed a sort of understanding of how to use all the equipment, what would be your next project?
I think building a set of stairs would be really cool. So that at Flywheel Industrial Arts, they do a lot of like custom stairs and decks and stuff, and that I've always been impressed by that, and I think it's you know, and they are able to mix wood and metal together, and so that would be kind of a maybe next step. So probably a set of stairs.
Like the floating stairs look, or do you think you'd have it with the?
Floating stairs look.
That's
For sure.
how I would picture metal stairs.
Yeah.
Floating.
Mm-hmm.
Cool.
My question was around the gases used, like, I know you say the weld, it helps the integrity of the weld,
Yeah.
because if it's exposed to like a lot of oxygen, it destroys it, but my wonder is that you're breathing in this gas.
Well, they've got basically large vacuum fans that you can bring down, and you got to keep it close to your weld because there's a lot of really noxious gases that argon is not necessarily dangerous for you, but a lot of the gases that go along with welding are it
Because a lot
can
of
be
times on
harmful.
the farm, people don't have that gas when they're welding.
No, but that's generally probably a more open air environment, and that's not. So when we're working in the shop, at least in the winter, the garage doors were closed, and so there wasn't a lot of airflow going on. So you don't want to be getting, you know, if there's 4 people welding, 3 or 4 people welding in there, there's a lot of gases that can build up,
Right,
which can, I think, are carcinogenic.
right.
That's some of the nicer things, learning from people that are trained.
Yeah.
Learn these things as opposed to, hey, try this at home, here's your tank. Not
Yeah.
worrying about all these other things, that's very good.
But I think it was also you know, a lot of times we might have to learn a lot of I'm not saying that my mentor at all, like, just ignored safety requirements at all, but it was definitely like, here's a welder, this is how you do it, go do it, right? It wasn't necessarily like a super long learning process, and of course, you know, the quality of my welds weren't great.
I think that's a wonderful way to start you off.
Yeah,
If
right?
The environment is safe, go to it, and we can talk after you've done it, that's
And it allows you to really create something before you're kind of stonewalled into learning a bunch of stuff, and then finally getting to create something. Any other questions?
Awesome job.
I go more in the middle.
No, you're perfect. You're good.
Okay. So my presentation is about, I should take this off first. My mask. There.
Keep it on.
Okay. Figured I'd ask. Okay, so my slideshow is about technology, blessing or burden. So my overview, talking about introduction, which is technology as we know it. Talking about the blessings, ease of access, spreads awareness, communication, saving lives, convenience. The burdens, cyberbullying, procrastination, privacy, cyber criminals, virus attacks. Talking about my field work that I've done, Skillsusa, what I've learned, building my personal computer right here. So my central question is technology a blessing as some turn it out to be? If any, what are the drawbacks to technology? So what blessings? Technology, is there any drawbacks? We use technology in our everyday lives, from our TVs to the phones we use, computers we use. So technology will always remain in our lives. But controversial questions remain, is technology a burden or blessing, or could it be both? So ease of access, technology gives us the information at our fingertips. You can look up anything online, the recipe or an answer to a question. It's also good for education because you can look up on YouTube, there's videos that teach you how to do stuff, like build stuff like that. You can find what you want when you want it. And if you want to find a textbook for like a college class, something like that, you can usually find it online. Spreading awareness. There's charities like GoFundMe, which provide people, they can go online and actually like write posts if they're in need of any help and funding, and people can donate to them. It also gives us awareness of pandemics, like how many cases we have per state, the red areas, how to prevent the coronavirus, for example, vaccine details, the effects from the vaccine, any symptoms, stuff like that. It also spreads news what's going on in the world, like military and stuff like that, different countries, what they're doing. And it can also inspire others to help people with certain causes. Communication. People can communicate to each other from over the world. Makes it easier, more efficient, and quicker to talk to each other online. And there's also apps like Facebook, I'm sure you're aware of, Snapchat, Instagram, which will allow you to build relationships with people online. It also comes in handy when we're in a said pandemic. Like Zoom, I know helped us out a lot with education-wise, and we could go on Zoom and do like conversations that way. Saving lives. Medical advancements have predicted amazing things for the future. One of those things is called Nanobots, which what they do is they enter into your bloodstream and they can intervene before any disease kind of appears. And they will be able to care for the elderly and sick children. And it's a picture of what it kind of represents. Convenience, you can shop online, you can find information while you're at home. If you lost like your phone or whatever, you can actually go on to apps like Lost My iPhone or Find My Device. They even have these little like rubber band like technology things, and you can attach it to anything like your wallet or whatever and find it that way. It made advertising easier. You go on Facebook and you can actually like, when you scroll through Facebook, you can actually see different advertisements and stuff like that, and also companies can make their own website to provide stuff. It spreads news quickly and gives access to better education. Okay, burdens. So we have cyberbullying and cyberstalking, and social media sites like Facebook allow people to write rude comments to people online. Little to no consequence. People also tend to cyberstalk people, which includes sending or harassing emails, hacking into someone's online account, banking and stuff like that. You can change your password. So 43% of people have been bullied online, and this number continues to grow. However, there are some platforms like Facebook or stuff like that, they try to prevent you from being able to do that, trying to find ways to prevent that from happening, so the number can go down. Procrastination. People tend to use technology instead of doing their homework. It can take precious time away from us. It can be dangerous as it takes away from you being able to do work and to work towards your goals. Which can include computer games, virtual reality, social media, which all can take away from the real world, and they're really addictive. Privacy, this one scares me a little bit. Your real personal data can be compromised online to hackers or even the general public. People can know a lot about you just by looking you up online, like the Facebook and Instagram, whatever. This can lead to identity theft. People can steal your identity. Obtain your name, where you live online. Even if you think your personal name and data is safe, it's not, because it's probably online. There are also some websites that you can actually go to, and they provide a database of all of people's names and locations, stuff like that. Cyber criminals, hackers can hack into almost everything and anything. And they can even get access to your bank account and credit cards. Russian hackers have been trying to hack the US government for personal information. Actually, in the news recently, cyber criminals actually hacked the gas line, and they threatened to turn the gas line off for people. It's called a ransomware attack. They're also now trying to go after the meat industry. They're trying to shut that off as well unless they get paid. So the types of virus attacks and what they do. So first we have malware, which is the basic term for a virus, and can be in the form of a program on your computer. The second one is called ransomware, which is a type of virus that will lock up your entire computer and will demand that you pay a fee to get it back. Usually a word of advice if that happens to you, never pay the fee, because it teaches the hackers to keep doing it because it tells them that their strategy is working. You have a Trojan Virus, which is, it will like dig deep into your computer's programs and it will try to hide itself, so you're not going to know it's actually there. And it takes your data, stuff like that. They're really annoying to kind of get rid of because you don't know if they're there or not, so you have to make sure you run different programs to detect that. We have Adware, which is one of the most annoying kind of viruses. It will make the computer slow, and it will show you a bunch of advertisements on the home screen, and there shouldn't be any ads on your home screen. We have spyware, which is the most deadly type of virus listed. Again, like Trojan, it'll hide from you in plain sight and steal your data, and it can appear as a regular program. And actually what it can do is if you're typing, like if you're logging into your bank and you're typing in on your keyboard, like your username and password, it actually can watch what you're typing and actually record that and send it back to the hacker to then steal your username and password. So my conclusion, you can reduce the burden of technology by changing your password every so often, using the correct antivirus software to make sure you're up to date, making sure that you are on secure websites and limiting how often you are online. Doing all these things can reduce some of the burdens I said in the slideshow, and it might make you better off when fighting hackers and making technology more of a blessing, as I believe it to be. Next is my field work.
I'm just gonna close the window.
Oh, okay.
Nice.
That's good. We need a little bit of air in here, I think. Yeah, thank you.
So next up is my field work, what I've learned in training to help prevent some of the burdens. So these are the best practices for preventing a virus. You can download antivirus software, you can make sure that the antivirus software is up to date. You also need to make sure your computer is constantly up to date, if you're on Windows, you can go to Windows Update. If your computer is slowing down, a virus might be the issue. It isn't always, but it might be. Again, if you see advertisements on your computer, like on your home screen, that usually is a sign of a virus. And if you actually ever think you have a virus, a best practice is to make sure your computer is not on the network, because viruses can actually move from different computers on the network. Kind of like leeches that can move to different computers on networks. So why is that important? It's important to keep yourself safe and others safe. If you work for a company, you could potentially expose a virus that could do a lot of damage. Viruses can steal personal information, such as, but not limited to, bank details, credit card information, personal identity, any personal files you had stored in your device. And like I said, they're like leeches. They can go from computer to computer, to the internet, and that's why it's good to know how to prevent viruses from even happen, or how to keep yourself safe online. So this is what I kind of did for a project, which is called Skillsusa. Skillsusa is an organization that strives to empower its members to be world-class workers and leaders. Every year, it provides students in technical centers a chance to compete in local and national competitions. So what I did is, for Skillsusa, my class and I were assigned a group of three, to build a super futuristic computer. We were given the parts by our instructor, and the components can be seen in the picture down below, which I'll show you in a second. After the build, we were graded not by our instructor, but by our statewide Skillsusa judges. The main objective was to build a working futuristic computer and ensure that it had all the security measures to protect from viruses. We also had to make sure that we could run a virtual reality headset to it. So right here is the tools we had on the desk. This is right here is the virtual reality headset. That here is the case we used. We have some cables, some coolers for the computer to make sure it doesn't overheat. Obviously our 2 bags we use the tools. So that's me working on the computer. I was actually unboxing the cooler so it doesn't overheat, and unboxing the memory for it so it runs faster. And that is me installing the cards, my hands right here. I was installing it into the slot on the computer. Down there is one of the fans I was installing, which is the white fan there. If I can even play the video. Let me see if I can actually play it. It's not playing. I'll have to show it after. It's not playing the.
Can you did you copy the link address to it? Is it on YouTube?
Open YouTube if you like, and
It's not really a YouTube. I have to go to here. Let me see if I can.
Pre-recorded, right? There's just someone up there doing it.
No, it goes off every night at 6, and it keeps going.
Has anyone brought it up on my front porch for it? Cool with the bells.
So that is what it looks like, the final result for it. Oh,
I think it's just laggy internet.
yeah.
Now, is that the water cooled one, Jeremy?
No, originally it was supposed to be water cooled, but as we were working with it, the computer to install the water cool for it, it actually ended up breaking. So we had to install a non-water cool kind of cooler for it, or a fan, which was in the middle here. It's being that fan, the cooler is the fan in the middle, this one right here. That one's not water cooled because ours broke. My team's water cooler broke. So we had to use the one that came with the computer. Right there. The antenna was for the Wi-Fi to connect to the Wi-Fi. It actually changes colors on the top as a button you can press, and it changes the front colors for it as well. That was the first video.
Looks very cool.
This is the full screen actually. So that is what the back looks like. It's actually see-through in the back, so you can actually look right at it. We have the cables and stuff Here, let me pause it, slow down. I'm gonna explain more of it. Okay, so right here, where all the cables are coming through, that is the board. That's the card that I installed earlier right here. This is when it was water cooled. That's when the cooler was up here. That's when it was before it broke. We have the memory, which makes the computer faster. These two little lights right here. I'm gonna play it. They change colors too. So the aftermath, my class ended up winning the statewide competition, and my team won the competition because we had 6 people in our class, and it was set up to 2 teams. I got second place, which is silver, and I got up to $1,500 scholarship to VTVLC, which I have the medal right here that I got for it. This is the medal that I ended up getting for it. So why I decided to enter this career path? My career path is all about making technology a blessing for others. And my job is to make sure how people feel safe online, using the correct software and tactics. I chose this career path not only because it's my main interest, but I also like to help other people and educate others how to turn that technology, all the burden, into a blessing for technology. And that should be it for my slide. I can actually plug in my computer if you guys want to see it.
Yeah.
Or-
And this is where we get to ask you questions. Is that okay if we ask you questions?
Oh, yeah, sure.
My first question is, it seems like a water cooler is a really bad idea around
Oh.
computers.
I
I'm
had a
wondering why
question
people,
about that too.
why they would invent
Well, it's
something where.
enclosed into like a casing, obviously, so it doesn't get all into the computer. And actually, they call it water cooled, but it's not actually water. It's they call it, it's kind of oil, and the oil doesn't actually like no, I'll explain the word. It doesn't actually mess up the electronics. If it gets into the electronics, it's kind of oil that they use.
Okay.
So does it, is that water cooler, which I was also curious about, does any of that oil escape in like a gas form? Or is it all contained and it's just like heating up the vessel?
Yeah, it's not heating it up, it's actually cooling it down.
Oh, sorry, cooling down the
So
vessel.
it's all
so that
contained
it
into
escape.
one kind of thing. It's it's all contained into the thing.
Gotcha. So there's no escape code.
No.
Yeah.
And usually we'll have to fill it, if it's a water cooled, you have to fill it with oil. There'll be a little place, kind of like a radiator, you have to fill it up. I'm gonna find where I put that. Right here.
So Jeremy, while you're plugging that in, I have a question. Did I hear you say you're going to VTVLC?
Either that or
I mean,
CCA.
I think it's BTC. I think you
Yeah,
meant
BTC.
BTC.
Yeah, I mean,
Yeah.
What is it?
It's
What
hard.
is BTC?
VTVLC is the
So many
Vermont
of them.
Virtual Learning. Yeah, so
Yeah,
I think
right.
you meant BTC.
Yes,
Vermont Technical College?
Yeah, it
yes,
might be VTC.
that's the one I know.
Yeah.
And so that's a scholarship for, what specifically? Computer software programming?
It's for anything that I choose really, but I'm not sure what I'm gonna be doing yet. Obviously, it's gonna be about technology, but
Now you take
I might
this-
do cybersecurity.
That'd be great.
Could be a thing. Yeah.
I'm also curious about the nanobodies. Like that is so new
Yeah.
to me. Like when do we expect to hear more about that.
Not quite sure myself, to be honest,
Oh,
but I was reading up on
Something
that.
to look forward to in the future, sure. Like, I'm thinking right now, people just are so resistant to getting a vaccine, that the idea of them injecting some type of technology to help, like, fight disease would be like asking them to give their left arm.
Well, depends who asks them.
Maybe, maybe, but injecting, would you be comfortable having them inject nanobodies?
No, that's
Oh,
I know,
Not right now.
and then the picture is not very appealing
But if,
either.
if Elon Musk has like his good marketing campaign around it, and he's like, this is awesome.
I'd rather go down in flames,
One thing I noticed about computers and yours here and the one that you designed with your team is that growing up and everything, computers were a tool, and I find that they're becoming more and more also art. Like you see lights that light up in certain places, and they're designed to be more appealing visually, and that interests me. And with the clear panels to see what's going on. That's really something that's new and interesting. So when you designed this one,
Yeah.
did
It was
you
the first
choose
one.
elements like that would make it,
Yeah, I
snap it up?
actually chose the case of it, what
Yeah.
was inside of it.
Yeah.
And this is my first ever gaming built, which is a learning experience for me. This is the first one that I actually ever built.
Yeah.
So,
Yeah, he's actually pretty excited. He's taking the second part in A+ tomorrow. So he passed his first part, doing the second part.
Look at even the keyboard, as you see, Megan, is the spectrum there.
Already taken a online college course.
Yeah, look at that. See? That's cool.
Oh, yeah, it's very good, it just draws you in.
I know.
That addictive quality, ooh.
Wow, and
a little bit
it's
with
got
that,
the,
yeah. Keyboard lights up too.
whoa.
How much did this whole setup cost you, Jeremy?
Close
Cost
to
about us $4,000
About
to buy,
$4,000.
just to buy the parts for him to build.
You guys spent $4,000 on this.
Yeah.
Wow.
Take the elevator on the way down for sure.
Ah!
Trip on the stairs.
Jeremy, he likes to have the best of the best.
Yeah.
Best graphics card, best,
Yeah.
perfect.
Thanks to the guys back here as well.
I
So,
haven't seen that before.
What's that?
Moving screensaver.
Yeah, that's amazing. Yeah, I just noticed in the water meter.
Oh,
yeah.
See that?
front
Water
light
bill
there,
is
Jeremy?
flowing.
I don't know what happened to the front for some reason. It's not lighting up anymore.
Well,
I wondered, like, as I was listening to your list of like all the burdens as well as the benefits of technology.
Yeah.
Like, I'm wondering if you at all explored this idea of isolation. And how, like, I wonder how much people are just not like being social creatures anymore,
Yeah.
and they're kind of going into a shell. I didn't know if that was anything that you ever explored as you looked at the burdens.
Yeah, I did definitely do some research on that. I do agree with that. People are sometimes actually kind of, you're right, like going into like a little shell. And without like to go into the real world now, because it makes it so easy for you to just go online and communicate and do homework online, stuff like that. There really isn't a need anymore kind of for in-person communication and kind of learning too. So it does make it kind of hard for in-person stuff now.
He did mention that in one of the slides, though, briefly. He did mention that.
I don't know why it isn't working now. I have to mess with it.
It's working
and-
right now, the lights are just turned on,
Yeah,
so.
I'll have to figure it out later, but you should get to see the lights and stuff turn on.
What are you trying to, was that your log on right there where you were working with there? Was that a security passcode for you to get on with that, with the number pad you had on the screen there? It was
When I
just
first on the computer.
when you were just clicking right there where you said I'm not, you had 6 little pictures there and it looked like a number pad below it and you were clicking that right.
Oh, this? This controls the lights,
Okay,
so I can actually change a little what it does, if it programs it.
got it.
I was trying to figure out to get it to work back to where it was, but it wasn't working. I'm still new to figuring that out, so.
Okay.
Yeah, that pretty much does it then. You guys have any more questions, or?
What was the most surprising thing you learned while you were doing your research?
The most surprising thing? You know, I mean, a lot of it was surprising, to be honest. When I first got into computers, I went to it last year, and just going into it and actually building one and working around them was really shocking to me. I haven't done anything like this before, so, I mean, to be honest, I mean, all of it's pretty shocking. There really isn't a single thing.
And the difference between an office computer and a gaming computer.
Oh yeah, I used to work
That
on
was a
like
challenge
office
for you.
computer, not like gaming computer like this, which are a lot easier to work with, less lights, less components.
I have to admit, when the boxes started coming in and the total started to rack up, I really made sure you know what you're doing.
Right.
Because when it came in, that box that you're looking at over there was empty.
Yeah.
And I thought, wow.
Yeah.
But he diligently put it all together, and of course I had my fingers crossed when the initial time came to plug it in.
Yeah.
Oh, sure.
It worked. I mean, it was good to see the look on his
You always have to
face.
try to turn the computer on, make sure that actually works.
That's satisfying. What about the frustrations, anything that was real finicky to get together, or anything that was a struggle?
We're trying to actually plug everything in because there's actually a big power unit under here, and it gives you a bunch of different like wires, and you're gonna plug it in to the board. And me having not the smallest amount of fingers, trying to plug in all the
Yeah.
different parts onto the board was kind of the hard part for me, because I have really big hands. So
Mhm.
The detail, yeah.
I sat back and I watched him do it, and he researched and researched and double checked, and I kept waiting for the
yeah,
puff of smoke, but I didn't have.
Yeah.
And just making sure that the parts are compatible, because you just can't go out and buy just
Yeah.
any computer part. You have to make sure everything's compatible.
definitely like.
Everything's gonna fit together.
I was going back to the blessing, definitely having Google to look up all the parts and to build it.
You
Well,
have to
like
make
I
sure.
say, he's built that, and I've watched him build it, and now we watched it run. We're ready to invest and have him build one for us.
Nice.
Yeah.
Yeah.
So, I mean,
Yeah.
a lot of the money, and when he first told me what it was gonna cost, I was like, hey, that's crazy, that's not gonna happen. But it's what's inside the computer is where all the money is. And
Sure.
it makes sense when you really sit down. It depends what you want out of a computer. So like my wife and I, we use computers for business, and we're forever going to Best Buy buying another computer every year because it's already outdated when you bought it. Where this one here, we can just keep changing the parts out. So it kind of made sense what he was doing.
Yeah.
It's also a lot cheaper because you're not, if you're building it than actually buying it from like Best Buy, because if you're buying it, you're paying for the labor, then I'm actually working on it, which costs a lot, compared to just putting it together yourself.
Do you have to learn anything, or when you're doing the research or putting things together, did they talk to you about anything like grounding yourself or worrying about a static electricity discharge? Anything like that?
Yeah, when you're building it, they have you wear like a wrist, like a strap,
Mhm.
and the strap plugs into the outside of the case to kind of make sure you're grounded, so you're not really, if you're inside touching all the wires and stuff, you don't shock yourself. So yeah, there is that kind of safety precaution you have to use, which I did learn, so.
I'm glad you learned it before you started.
Yeah, that definitely would have been a,
The funny thing that happened during the build, which it was good to see his face, because I'm a person that just watches people's faces, and I heard it fall. I heard the tick, 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 tick. And then he just looked at me and I went, oh, let me guess, a small screw's in
Yeah.
there somewhere. Try to find it.
Oh,
And you have to find it. You gotta
drop
stop.
the screw in there and I
And it's
find
not
it.
like you can pick it up and start shaking it.
Yeah.
You literally had to get in there and try to figure out where it was.
Yep.
Yeah.
Huh.
Yeah.
Very impressive.
So I'm sure there's all kinds of weird angles that you
Yeah,
have to things at.
really hard to get your hand in there and actually like plug in the wires and do different screws in there.
Yeah.
It's just so tight sometimes in there when you're working.
Was there any thought to like trying to put things together outside of the box and then trying to slide them in afterwards as opposed to having them placed in there and then connecting?
So you can do that. You actually can build all the parts on the board first and then just put it in. They're not all the parts work like that,
Sure.
but there are, because you have to actually, not all the parts work like that, but most of it you can build outside the case. But there's still some parts where you have to plug everything in and put it inside the case, stuff like that. So
Like just that mouse to get it to go the rainbow. How much was that? I'm curious.
with the mouse, like $20. It wasn't really.
So just getting a mouse with a rainbow.
Yeah. They're not really expensive.
Well, the mouse and the keyboard were probably the least expensive.
Yeah, definitely.
Yeah, that makes sense. Those are, yeah.
Well, even like the reason I'm asking is they're showing us the colors and they're changing, so they're not as expensive as the other parts would compared to your basic model.
Yeah.
But it's where you want to be.
I love doing this. I enjoy it.
Good
So
for you. That's great.
Well, thank you so much,
Thank
Jeremy.
Well done.
Good job. Now,
Frankie, how are you?
Nervous, but,
There you go, bud.
you are not alone. The last two guys that were up here were so nervous too, Tyler.
We had to use a mop to get the sweat off the floor.
If you want us to open the window behind you too, because it gets hot, let us know.
yeah.
Do you want us to open that window right now?
Sure.
Yeah, can you do it? Because you do the shovel. You got the trick. I'm offering something, but making. Oh my God, that's a typical. I'm sorry. Just be happy you don't have to deal with me all the time. My husband hates it.
Well, that'd be great fun if you did that.
Do it. Oh,
Alright, so I did my senior capstone on welding, and what I found in the welding process is a lot of things that I did not know about. So we're going to start with my overview. The introduction is going to be my essential question and a brief history of how welding started and evolved, and like what is welding as a whole. Then I'm going to investigate welding, like how it gives you a better paying job, how it helps you fix metal parts and like on vehicles and just in general like buildings and stuff. And then how it's also a fun hobby to get yourself into, because if you're interested in like carpentry or something, you can build furniture with it in a certain way. Like I'll show you briefly on the slide. I'm also going to show you the injuries, how to what to wear and prevent injuries, what can happen to you if you're not safe, and some long-term injuries. Like I have some photos that show long-term injuries, and then my final research. So my essential question: why is it necessary for people to know a trade like welding, and how will they use it to get a better job in the future, or something like that? And probably a lot of people are wondering, what is welding? Welding is joining two metal pieces or parts together by heating the surface of it to the point of to the melting point, and using a blowtorch, electric arc, or other means necessary to get it hot enough. And I'm uniting them by pressing or hammering together. Okay, so a brief history. Welding is a skill that's been around since 1836. It was invented by a man named Edmund Davy, or Davy, I think, I'm not sure how to pronounce his last name, who had discovered acetylene, which I'll go back to that in a minute, for what that is. In the mid-19th century, the electric generator was invented, which started arc lighting, and that's how it became popular. And then during the late 1800s, gas welding and cutting welding was developed. It started with a man named Auguste de Marintins. He was the first to use arc heat to join plates together. And I have a video talking about it a little better than I think it does.
This beachfront.
This happens to us all the time.
Yep, it's all good. Yeah. And we're not gonna pay for entry. Listen for
218, it said, yeah.
218.
Yeah, it's good, bud. You're good.
Petrov emphasized its use for a multitude of applications, especially for melting metals. In 1881, the first electric arc welding method was created by inventors Nikolai Bernardos and Stanislaw Oswalski, known as carbon arc welding. With this method, carbon electrodes are used to generate an electric arc between the electrode itself and the base materials. The temperatures produced were high enough to form a bond between separate metals that eventually become welded. By the late 1800s, arc welding saw further advancements with the invention of metal electrodes, pioneered by Russian inventor Nikolai Slavinov and American engineer C.L. Coffin. Metal electrodes later improved around the 1900s with the development of a metal mixture coating called flux. The flux would give off gases as it decomposed to prevent weld contamination. This new design was accredited to British scientist A.P. Strominger, which gave a more stable arc and improved the overall weld quality. As the 20th century progressed, a plethora of welding methods, such as resistance welding, thermite welding, and oxy-fuel welding was developed, but fell out of favor for industrial applications. They were largely replaced with arc welding, as headway was made in the advancements of flux. The benefit of flux coating the electrode is the gas shield it creates to protect the base material from impurities. During World War I, welding saw a shift in demand as military powers used it in the construction of their fleets. The British Army primarily used arc welding, and to an extent, to construct the hull of some of their ships. Arc welding's applications extended to the construction of aircraft for the first time during the war. In fact, some German fuselages were even constructed using this process. The 1920s then saw the introduction of automatic welding, in which spooled electrode wire was fed continuously. But the biggest hurdle was how to protect welds from the effect of oxygen and nitrogen in the atmosphere, which led to issues with porosity.
That went too far. But they talked about how it evolved over the time, and during World War II or World War I, they started using it to create boats to make them stronger, and the planes to make them stronger and keep them tighter. So that way, when they were overseas, heavy waves wouldn't crash into it and break open the bottom and then sink the ship. Or heavy winds wouldn't make it so the wings on a plane wouldn't fly off easier. Now back to when I was talking about the acetylene. I looked it up and it said it was a small molecule made of 2 carbons, 3 hydrogen, and 1 oxygen atom. Which I still don't know exactly what it is, but I'm guessing it's some kind of metal that helps keep welding together, or a good type of metal to use with welding. Arc welding with the carbon arc and the metal arc was developed in resistance. Welding became a practical joining process. Well, alright, this is the 4 main types and sort of like the meaning behind them. So Mig is gas metal arc welding. Most professional welders will use they'll either say Mig, or you'll see on documents GMAW for short. TIG is a gas tungsten arc welding, which its abbreviation is GTAW. Stick welding is shielded metal arc welding, which is SMAW, which I mostly did stick welding, and I didn't really enjoy it much because the stick kept falling off the weld. So it's kind of difficult, and it's easy to get the stick or the rod stuck to the metal if you're not careful. Flux cord arc welding, I think is with a lot of electricity behind it, and that is FCAW. Now, investigating welding, that's someone grinding down metal to make it easier to weld, because welding, you can't just take any old piece of metal and then put it down, clamp it down, and then try and weld it to anything. Because the rust makes it difficult for it to melt and then actually bond. So you want to use a grinder, like an angle grinder or something, grind it down so it's got that nice metal, shiny surface again, and then you can start melting it down easier that way. So that's why I chose that photo, because you can't just take any old piece of metal and think, oh, I'm going to weld this together. Alright, a better paying job. So I looked at statistics of all over America, what is the highest and lowest paying jobs around. And I looked between $19 an hour and $30 to $45 an hour was the highest. The lowest was $16 to $14 an hour, which is still not terrible, but I mean, depending on where you live, obviously welding is needed more than other places, so they're going to probably raise it up higher if it's needed more. Some of these jobs, the welders have to be away from their families for a very long time, and sometimes the welders are unfortunate enough that they'll either go to a job site across the country or across the world, and they won't see their families for months or a year, and then they'll get a call from their boss, be like, hey, once you're done this job site, we need you here as soon as you're done, which can really kind of put a mental toll on the welder, because not getting to see their family. So they're making all this money, but they're not really getting to spend time with the people they're actually making the money for, which is a downside to welding. So, yeah, there's that. Different jobs in welding. So I looked this up, and I found some interesting ones that I personally thought were kind of interesting. Underwater welding. I did not know that you could weld underwater. I thought you had to build a pipeline and then lower it with a crane and then find a way to put it together that way. So, underwater welding, you need to go to a special trade school, get certified in diving, and certified in all that, and then you are pretty much certified to do it. But it's kind of dangerous because you have to be careful with sea life, you have to be careful with how much electricity you use, and how much air oxygen you use, and how long you're down there for. You also have to be careful certain areas where you weld, because it could just break with all the water pressure getting inside and just popping. So you definitely gotta be careful. Military welding, I did not know this either, but gives you free welding training, which, I mean, it's really not that big a deal because the type of welding I was looking at in the military was vehicle welding, but it is a big deal when you are getting free welding training, and then you're also, on top of that, you're going to end up getting benefits just by welding all day long on vehicles. Pipeline welding, all you have to do is assemble, install, and repair pipes that are broken. And you also have to look at systems, like on the pipes, according to their specific type of pipeline. Inspect materials on the pipeline. You gotta inspect your equipment, make sure that's all good and safe. You have to look at your tools. Most importantly, you gotta clean your tools often because you don't know when or how long you're gonna be on a job site and then where your next job site is gonna take you. Iron workers, their job involves heating, cutting, bending, and installing sometimes very large metal components for structural work. They also travel around the world and spend a lot of their time away from their families. Those guys are the ones I was talking about that didn't really get to see their families more than other welders, because the iron workers are needed all over the world pretty much. These are a couple welding things, like pieces of metals like in vehicles that you can weld. Tractor hydraulics you can weld. If part of it breaks off, you just weld it back on very carefully. You can be dumb when it comes to welding. I learned that myself. Vehicle frames, if your vehicle frame is cracked, I know a lot of people's vehicle frames are cracked and they just welded them back on. It's not a permanent solution, but it helps for the meantime because no one wants to just go off and go to a dealership and have them or an auto repair place and have them tell you, yeah, that's going to cost you like $65,000. Some big number on it. And then they also do welding for manufacturing parts, like that bracket right there. Yeah. It's easier to just honestly weld your frame or anything like on that if it's a little busted up. Like I don't advise someone to just, oh yeah, your frame's cracked in half, just weld the whole thing back together, it'll be fine. But if it's like a little crack, it'll be okay for a little while, you know. Because I know a lot of people, they don't want to spend an arm and a leg at a dealership just to get the vehicle part replaced or something like that. So it's just an easier kind of way of making it so you don't have to spend much money in the meantime. I also looked at another aspect where welding can be used for iron structures, or iron statues, sorry. I personally really like the dinosaur one in the middle, because I love how the dinosaur's mouth is wide open, and it looks like he's about to eat the guy's hat, something. Also, my little brother saw that, and he's like, you better put that in your project, so I was like, okay. But I also love the fact of just seeing people put metal things together, like pieces of metal together, and making something really beautiful. Like the horse, taking all that time and making sure they don't mess up on the feet, because the horse's feet are kind of different looking than a dinosaur's feet or a bison's feet. I really like how they made the horns on the bison look very realistic. Or in the dinosaur's beak-like thing, I really like how shiny it is as well. How they really focus the details on what the dinosaur looks like, or what the animal looks like. But I definitely like the art aspect as well of the way you can do it. I also saw that some people use their welding talents to either build chairs, tables, like that. That's the start of a table. I kind of like the design on it, the 4 or 5 squares, all but each corner of the middle square is on the opposite side of on each 4 of them. Kind of makes it like a family kind of thing. I also had a friend that talked to me about this, which he had me look at this, and he said that he knows someone that made their staircase from welding. Like they took the time and effort to weld their staircase, perfectly. They didn't have photos, and I wanted him to give me a photo so I could see what it looked like. From what he told me, it looked like a regular old staircase, like right out here. It looked perfect. And I just admire people that take the time to just slowly do that process and work just to make it look amazing. Now we're going to move on to the injuries. So, welding is not something to goof around with. It is very dangerous. You can get very hurt. You can lose a limb, like that man down there who lost a finger. Your skin can burn off if your hand gets too close and you're not wearing a glove. And your eye, a lot of damages can happen to your eye. If a piece of metal goes in there, your eye can swell up, and that can really mess that up. If you look at welding, like if you're welding and then you see flash without a helmet, protective gear needed, you can go blind. You can get arc headaches afterwards, which hurt really bad. I sort of got one when I weld. I did not wear a mask the first time, and yeah, I did not enjoy the headache afterwards. But you definitely want to wear some kind of gloves, not winter gloves. Winter gloves will get torn through by that heat. You want to wear specific gloves, sometimes even sleeves if you're grinding down the metal as well, because that metal will hurt your arms. And if it's the sparks also are like it's like 1200 to like 1500 degrees Fahrenheit. So you kind of want to keep your arms and body parts safe from the heat. You also, when you're on a crew, you don't want someone just playing shove, because A, the person that's going to get shoved is getting shoved, could get shoved into the welder. B, the welder doesn't know what's going on, and he can get hurt because he might turn around or get pushed into, and the welding rod or electricity could zap him and really give him a bad day. And the welder you do not want to mess with, because he is really trying to pay attention to his job. My final research, I'm going to talk about my meetings, the different type of welding rods and sticks. There's only 2, but they are very fascinating in my opinion. In my actual welding experience. So, during the meetings, we met, and the first meeting, he told me straight up, I don't know how to teach someone how to weld. I was never taught myself. I've never taught anyone, but I can show you how to do it. First time he showed me how to do it, I did not understand what he was talking about. He was talking about electricity stuff, like certain volts you need, having a ground, which I understood that, but having a ground to make sure that the electricity didn't zap you, because the bench we had was an iron bench. And he never told me how far away or how close to keep the stick on the piece of metal I was welding. So a weld, my first couple welds did not look great. But he did tell me what a good weld looks like. A good weld looks like a straight, solid, melted piece of metal with waves going toward y'all, And a bad weld is pretty much like it looking like crumps throughout the way, like a little bit and then no weld and then weld again and then space. You don't want spaces because that just makes your weld weak. The different types of sticks that he told me was two different types. Which one? One was 32-30, which you don't want, or maybe it's either 32-30 or 30-32. I think it was 32-30. But that one's a big welding rod stick. You do not want to use that for tractors. The reason why you don't want to use that for tractors is because that you want to be careful with that kind of rod, because that rod is so big that it could break easier than the tinier ones, believe it or not. I broke it. I broke one, got yelled at. So I learned from my experience not to be careful with that kind. Now the 1612 rod, it's a lot tinier, but it's way better for tractors because you don't really have to make it look good. You just have to make sure it stays. That's pretty much what I was taught. If you have a tractor, just do it like that, because it's just so tiny that it's not a very big weld that you needed to do. It's just, if you make it big enough to stick, or if you make the weld good enough to stay, that's all that matters. You did a good job. My conclusion. So, welding is, it's kind of complicated. If you know how to do it, remember to be safe about it, and you can help people, help someone with their vehicle if they break down. You know how to do it, they have a welder, you can just help them fix that vehicle frame, something. But being careful and safe is the main thing to take away from this, because there are a lot of people that get eye injuries because they think they don't need protection. Because people with glasses, this ain't gonna protect you, if you will. It's not. It's just gonna reflect, and then it's gonna definitely make you blind because you're getting double pretty much the arc lighting. Yeah, pretty much just that. And OSHA also states, because I looked this up, it says OSHA for everywhere. Horse playing around? No. Be safe? Yes. That's pretty much their motto. They always talk about being safe. So, yeah.